So let's get started. My name is Manoj. I'm actually leading operations team within HCL Software in Noida, Noida, India. So I'm responsible for reliability, performance, and availability of various HCL software products which are getting delivered as SaaS service on different cloud platforms. That includes Google, AWS, Azure, and IBM, all four major cloud vendors. So today's talk is all about how to optimize AI, especially in the new generation when the complexity of the application. Everybody knows, right? With all microservices, lot of integrations, external integrations, hybrid cloud, the complexity is increasing day by day, and operations of these applications is becoming very challenging. It's no more like kind of a monolith application where you just monitor a single server. It's not no more the same story. You have hundreds of server running hundreds of microservices. Each microservice might be having tens of replicas. There may be tens of DBs. Those DBs may be cloud managed. Those DBs may be your own self managed. They may be in VM machines. There may be queuing mechanism, caching mechanism, and other lot others components which actually when clubbed together, combined together, make an application. So operations of such applications is very laborious. You need lot of people if you really want to do that manually. You may be needing hundreds of screen, hundreds of dashboards, some people monitoring those dashboards, looking at them, still missing a lot of stuff. I mean, still there are a lot of things is missing. So not scalable. I mean, that way it's just not scalable. So that's where the whole concept of automation and AI comes into picture. Uh, we all know, right? AI is there everywhere. I mean, if you go to development, DevOps, testing, and other stuff, everywhere the AI is there. The same way in operations, AI is bringing a lot more optimized, a lot more scalable environments. So we'll talk about all that, how to infuse AI in a different ways. What is the best way to infuse? We all talk about Gen AI, LLM, but that's not the only AI available for all the use cases. So we'll try to figure it out what the best way to fit, which models best fit the AIOps things, what are the objectives, what is actually AIOps. We also like to define that because even the definition differs from vendor to vendor. Many vendors talk in a different way when it comes to AIOps. So whatever I will be showing today, that is mostly my work. No chat GPT involved because I know a lot of people we generally use chat GPT, but there's no chat GPT involved. Most of them is my own work. I do play with different vendor products, tools available across the world related to observability and AIOps. Take out good things about those products, give feedbacks on those products, try to build my own architecture based upon goods and missing parts, and try to build something which is really useful for my own use cases. So let me start sharing my screen. Every 4 to 5 slides, I will get a pause. I will try to see if there are any question on the chat. We'll try to answer that question before we move ahead. Objective is that whatever I cover, it should be covered in a way that everybody understand it. So I'm not here to cover the whole slides, but whatever we cover, everybody should understand. So feel free to add your questions to the chat. Every few slides, I will come back to the chat. We'll try to see what questions are. We'll try to answer that question, and then we'll go back and continue the slide deck. So let me just share my screen first. And maybe you can just confirm me if you are able to see my screen. Just thumbs up or say yes over the chat. Okay, thanks a lot. So this is the topic of our topic, AI in observability and IT operations. First of things, when I talk about AIOps, I'm not differentiating between SaaS operation and IT operations. I know both are different, but underneath concept of AIOps is same. As I said, many vendors define AIOps in a different way. old definition of AIOps is generally the AI in IT operations and not software operations. But my definition extended it to software operations, which we even call observability in nowadays. We do not call it monitoring, but new things we call it an observability. So I will say it AIOps is as AI in observability and not AI in operation. But just to cover both stuff, I said AI in observability and IT operations. But we will mostly concentrate on observability, which inside it has IT operation anyway. Okay, so that's the agenda. We'll cover very basic of observability for the folks who, for them, observability is new, which I doubt, considering the kind of, if your background is operations, I'm sure you might have heard of observability at multiple stages. We'll try to brief about that before we actually jump on to AIOps. AIOps is our major section. We'll try to cover what AIOps is, what capability I am looking at in AIOps, how to select the model, which model fit best in AIOps. We take a couple of examples of AI capabilities and then try to deep dive into which model suits which capability. And last but not the least, I will try to cover a very high level architecture of how things works in AIOps. And if time permits, we'll talk a little about agentic AI, which is actually the next level after AIOps. Okay, so in general, when we talk about monitoring, we talk about alerts. Alerts, when we talk about alerts, everybody thinks about CPU usage, memory usage, disk usage, my database query, mm, response time, error rates. These are few things which comes into mind when we talk about observability or when we talk about monitoring. And when we talk about alerts, most of us might have seen alerts which says my CPU usage is more than 50% or 90%, whatever threshold you set. But the basic question is, does that actually boils down to what are the user impacted? What is actually impact on the application? And generally answer is no. 90% of the alert does not tell you about what is the user impact, what is the end user impact. While our objective is to make sure the applications are up and running, they are available, they are performing well, but our alert generally talks about something internal, CPU usage, memory usage. It doesn't talk about saying that, okay, these users are impacted, or this page is not loading properly, or the order has been failed, or something of that sort. Generally, we didn't talk about that. So there's a big gap. Whenever alert comes to me at the night 3 a.m. saying 90% CPU usage, it doesn't talk about is there an impact or not. So it's very difficult for me to decide. Should I wake up or take a look, or I just go and sleep? And that decision required some kind of evaluating the impact on the application first. If there's an impact, yes, I have to take an action. If there's no impact, I don't need to. So converting this alert into something very useful, which can be actionable, which allow me to make a design, that change is actually an AIOps. That's what we're going to talk about. So I want to convert my alert, which says high latency, or I will say there's a slow response time, to something which is visible on this, which I generally call it as contextualization of signals. So you have something which says there's a high latency, there's a high response time coming in, but I don't want just high latency. I want somebody to work for me and give me something like that. That API X is experiencing high latency due to increased response time in its dependent service Y, which is linked to a spike in database queries. And that database load actually surged by 50% recently, flowing a large influx of user traffic from region A. Additionally, there was a deployment to service Y or an hour ago that introduced a less efficient query pattern. So this is something very specific what happened. It also says mitigation steps include optimizing the query in service Y, scaling the database to handle the increased load, and temporarily throttling requests for region A to stabilize performance. So it is actually talks about, gives you the whole detailed issue as well as what should be the mitigation steps. If I see this in my alert, I'm happy. I just wake up, I might be having runbooks which actually scale up a database. I might be having a runbook which actually, or maybe some configuration we say throttle it. I might be having some kind of a test result of this deployment of service Y just to verify that if that service Y has brought something new. So something which might have taken me hours to decide, it might just take me a few minutes to actually mitigate the issue and fix. So that's what monitoring the observability different from monitoring. We are not talking about CPU memory high. We are actually talking about what happened and how to fix it. And that's the observability plus AIOps, which gives you. So that's what we are going to talk about. So in general, if you see the observability definition, observability aggregates all data produced by all IT systems and correlate to find insight not easily anticipated by DevOps or SRE. We just not aggregate all data points. When you say data points, we generally talk about metrics, traces, and logs, sometimes profiles, and sometimes even events, and a lot other things can be added to it. So collecting all these 4 or 5 signals together in a way that you can correlate them. So I will talk about correlation in a separate in a separate slide on that, and the correlation, how you can do that correlation through usage of AI. Talk about that later, but that's how observability is defined. It gives you a visibility into the health of the system and impact of one component on another. So this one component on another and health, that is what it differ from monitoring. Monitoring generally talk about internal components health. It doesn't talk about health of the overall system. It doesn't talk about the dependency of one component on another component. Required for distributed system, we already talked about that. Today's environment or today's application are distributed by nature now. There's no monolithics no more. So we need to have this. Correlation help figuring out the root cause. So we'll talk in detail later stage how correlation help finding the root cause and how AIOps can help it. But that's how overall is summarized how observability actually look like. The signals, metrics, log, traces, profiles, and events, the 5 of them. You can add more depending upon your custom requirements. But these are the signals which generally are standard across applications, irrespective of the tech you use. You use Java, you use Node, you use Python, whatever the tech you use behind the scenes, they are quite standard across them. So I'm sure everybody understand that metrics are generally a time series of anything. It's a counter or a gauss, time series of CPU usage, time series of throughput, latency, error. It just give you a graph at any point in time. What was the value? That value can be just a counter, that means increasing, or a gauss, mean increasing, decreasing, both up, down, things. So there are others. Logs, I think that the basic monitoring or basic things is coming from generations, from the time applications are being written or software are being written, logs are there. So everybody understand that. The difference now is that in the past, logs were normally unstructured, and nowadays applications are started writing in a structured way, in a formatted way, so that machines can read it and interpret them. Traces are very important for distributed systems. This is like the whole user journey from the time user click on the browser on a button till the time response came back on the same browser and give you the whole page new page in there. So what is the whole journey? It's coming from browser to your HTTP server, web server, from there to your app server, from the app server it might goes to different microservices. Each microservices may end up using a DB or a caching mechanism or any other, or it may be integration with any external third-party system, maybe a payment gateway, or maybe any weather or any other external integration. And then it actually returns back the whole journey, whatever the output it calculates to get back to your browser, and it actually show you the data in there. So the whole journey, one click, what happens across the system, that make a trace. And in each trace, in each component, let's say it one microservice, what happened, that is called span. So the whole flow of spans is actually make up a trace. So that's the trace is very important. I mean, especially in the distributed system, we'll talk about that later. Profiles, new signal. I will not say new signal, but recently it's being reached to a stage where you can enable them in production. They generally give you a resource usage on every call. So each method, how much CPU your method is taking, how much memory an individual method is taking, and that is very detailed information. I mean, at a method level, at a statement level, you can check what memory, what CPU is being used, and the kind of agents which comes for profile, they are light enough now that, or claim to be light enough that you can actually enable it in production to do that. Events are something like something really interesting happened at any point in time. For example, a null pointer exception happens, right? It do go into logs, but it's an event also. Event may also be something like you get a deadlock in DB. That's an event. Something which is very interesting, which is not usual, that become an event. So these are the five signals. Generally combined together gives you a lot of information and insights when used correctly through AIOps. So I'll stop in here to check if there's any question on observability before I actually move it to AIOps concepts. Okay, so I do not see any. Please do write any question if you have, and I think Vaishnavi is putting some polls also, so feel free to add your option there. So there's nothing right or wrong in the polls. There are just to know understand what you feel about something. Okay, let's jump on to AIOps again. I don't take definition from ChatGPT. It's my own way of explaining AIOps. So operations or observability, I can change operation to observability with augmented capabilities of AI. So when observability is being used along with the capabilities which AI can provide to provide insights, that become AI ops. The few of the capabilities which I have added are predictions. AI can do predictions very well. I mean, given the historical data, it can actually predict prediction along with anomaly detection. So I'll give an example here. What kind of a predictions we are looking at in observability. Let's say you have a throughput where you generally see in the morning 6 a.m. your load is very less on your application. It built up. It went to the peak at around 2:30 in the afternoon. Maybe let's say 1,000 requests per second, and then it goes down in the evening and around 6 7 p.m. It again boils down to very small 50 or 100, and in the middle of the night it's almost close to zero. So that is a normal behavior of your throughput. And sometime what happened is this is normal behavior from Monday to Friday. But on Saturday, it's the other way around. You generally see a lot more high input or high throughput in the evening time, but in the daytime, it generally remains very low. So Monday to Friday, it's like a bell curve, morning low, afternoon high, evening again low. But on Saturday, Sundays, it's generally in the evening when it's very high. That's the normal things you have. Now, what happened is your AI can learn this pattern. AI can learn this when it's high, when it's no, and it's also based upon the days also. Like on Saturday, Sunday, it's evening. On normal days, it's in the afternoon. But then it predicts based upon this for the next 1 or 2 weeks. What will be my pattern? And then it start comparing the next 2 weeks prediction with actual value which is coming in. And if this actual value differ from the prediction a lot, there is a problem, right? So that's how AI can augment detection. What is happening in general by default? If you want to put an alert, it's very difficult, right? It's a kind of a varying thing, right? In the morning, it's very low. Afternoon, it's very high. Evening, again, it's low. Saturday, Sunday, in the evening, it's high. Morning, it's low. It's very difficult to put an alert on this. How will you do that? I mean, if you do whatever the rule based you do, you end up having a lot of noise. You end up having alerts which you may not want to take an action upon, right? So so AI can help. It can actually learn. It can actually predict, and it can actually compare with actual the prediction, and then it give you alert only when actual value is far beyond the limit of predicted values, and that way you can reduce your a lot of alert noise, actual things. And it can even go to an extent not just weekly seasons or a monthly seasons, even yearly seasons. In the November month of every year, my load is totally different from the rest of the months. Even such kind of things it can detect if historical data is there. And the next November, it will actually compare the values which was around in the previous November month, and not with October or September or the previous months, right? So that's the AI power. It actually can, of course, it needed data, but that's how the prediction and anomaly detection. It augment this feature actually augment observability for better alerting. Next, correlation and relationship and reasoning. Correlation is very important. I will talk about that in detail, but that's where it helps in us figuring out the root causes of the things. Uh, if you see in any application, right, especially again, we talk about distributed application, there are hundreds of components involved. A call B, B call C, C call D, D call E. E might be having an issue. But what happened is E's issue is actually become hidden because E has given a problem, D started giving you a problem. Now D started giving you a problem, C started giving you a problem. So this problem actually cascade to the parent. At end of the day, because you didn't have a proper alerting on D, you got an alert from C that there is an issue. But C is not the reason. Reason is E. So so that this relationship that A is related to B, B is related to C, C is related to D, and D is related to E, this relationship need to be understood properly. If you don't understand that, then your shift engineer will continue to debug B or C, while actually the start problem started happening from E actually. So AI can understand this relationship from the way your traces are there, the way your calls are happening, the way the past issue has happened. It actually understands these relationships and can easily figure it out that if there is a problem in C, there may be a possibility that its child DE might be having an issue. It actually look at DE's data to understand if that there has an issue. And I'm just talking about only 5 components. It looks very easy, but when there is a graph, right, interdependency, A to B, B to A to D, D to B, and there's a lot of crisscross of dependency which is happening, it's become very difficult to figure out those relationships, especially from the manual intervention. And that's where relationship and reasoning can help. And that is again an AI capability which help you do this faster. AI agent and auto healing, that's again as next step. We'll talk when you have the prediction, you have proper alerts, you have proper reasoning, relationships defined, you know what the problem is. It's always easy to create an agent which actually take remediate action. You don't have to have a manual intervention in there. So everything going well, AIOps can actually help you 95% of your operations fully automated if it is properly implemented. Okay, so AIOps objective. I divide objective into 3 sets. Again, people may see it in a different way, but I define it with 3 big level categories: before incident, during incident, and post incident. Everybody understand incident, right? So there's something happened, downtime happened. So when incident is not there, I mean everything is work fine. Still, my AIOps agents or the person or whatever the tool I have, it continue to look into proactively to detect if there is an issue predicted after some time, so that incident doesn't happen. And as my manager generally says, the success of operations is when nobody knows there is an operations team. That means operation team is not getting involved at all. That is the success of operation. That's the success of reliability and observability to that. So that's where it comes. If we checking proactively things, fixing things proactively, the customer or the DevOps or the dev team will never know there is an operation team behind the scene, because they come into picture when there's an incident happen. User come into picture when there's an issue happen. Dev come into a production environment when they found some sev1 or a bug coming in there. But you have acting proactively, these 2 things will never come into picture, and development or user will say there is no operations team exist, and that is a success actually. So you are making your own job obsolete kind of stuff. So, but that's, yeah. So we work proactively, and then during incident, AIOps can help you improve time to resolution. Downtime is very costly in some cases. There are penalties, there are loss of revenue. So you want to fix things very fast. So AIOps help you improve time to resolution, as I talk about correlation and relationship, right? If those pictures are in front of you, as soon as incident happen, A, B, C, D relationships, and there is a connecting vision date and all the things, then it actually really helps immediately. You don't have to go through textual logs and other things to analyze. Faster root cause, incident happened, it got fixed, but then you really need to know what went wrong, right? Faster root cause analysis. So that's where the RCA comes into picture. Again, correlations and relationships actually help. And we will talk about causal relationship in next slides. That again, another case which helps in figuring out RCA. So I defined before incident, during incident, post incident. These are the objectives which we took at. AI usage. So before I jump on now next, I again will just go back to the chat to see if there is any questions here. Okay, I see all the polls, but I do not see any questions. Okay, so let me go back again. AI usage in ops. So if you see this slide, this is not talks about AIOps. It's in general how your AI usage is valuable, right? Everybody want to use AI, but how to make sure that usage of AI is actually giving you a value. It's just not a buzzword to be there in your setup. It is actually giving you a value, right? So there's a prerequisite to that. If you want to get a value out of AI, there's a need of data quality. So your data should be good enough for the AI to understand. If your data is very poor, I will talk about a little more about data quality in the next slide. But if your data quality is poor, you use whatever AI you want to use, you use whatever compute you want to use, spend millions of dollars, you will not get the output. Your data quality, that's why there's a data engineer designation which is being highly paid today. So you need a good data quality. Your model accuracy, based upon your use case, your model should be accurate enough. Again, it's all depend upon training. It's all depend upon selection. If you select a wrong model, you keep them trained, you give them as much data as you want, they will not give you accurate result as per your use case. So the model selections matters. Model training, of course, matters if you have selected the right model. Interpretability. That's a little uh, I will say connected to AIOps, but even for other use cases, a lot of people talk about it. Explainability, trustworthiness. If my AI has taken a decision, can it explain why? And most of the time, that's where the AI fails. Most of the AI do take a decision, but they are not able to explain why you are taking that decision. The reasoning behind that is really important. And in AIOps, it's really important, right? So if my AI is saying that your database actually is corrupted, that's why there is a problem. I can only believe in it and take remediate action only when it's able to explain why it thinks so. Just blindly, I just don't go and start recovering the database from the backup, right? Even when the data is not corrupt, issue maybe just 2 minute fix, maybe a network issue. Because AI told me that your database is corrupt, I just don't go ahead and start taking an action until and let it explains why it thinks so, and that explanation is actually convincing enough to an SRE to do that. So that's very important. Again, that's where the trustworthiness goes. We all talk about hallucination and all those stuff, right? So your AI should be trustworthy when you are taking a decision. So AI might have decided, okay, this is my run book which I need to execute against this RCA. So can you trust that this RCA, this run book is really actually helpful when such issue happens? So that's the trustworthiness. So that, so these three, when combined, you bring in a good quality data or clean it. You bring in a right model, train on the good quality data, and your model is explainable. Can explain why it's saying so. That is what makes a better AIOps model there. So we'll talk about all these quality, accuracy, and explainability maybe in the next set. Uh, let's and we'll go one by one. So we'll talk about data quality first. Okay, let me just take a look at the time also we have. So let's talk about data quality. I'm sure everybody might have heard of OpenTelemetry. So I will not get detailed on it. I will just try to explain why OpenTelemetry, right? So I'll just give you a very basic example. We understand trace, we understand metrics, we understand logs. So when a trace flows right from your front end to your backend might be running, let's say in a Kubernetes cluster. There's a port which is actually fulfilling that request, and that port has a name. So in your whole trace, one of the span will be from this port, and the span will be having an attribute which is actually containing the port name. Similarly, in logs, the same port, because it's running a server, it's running an application, it's logging. It might be logging the port name in the logs also. And then this pod might be having matrices. We might be monitoring, let's say, a CPU usage or a heap memory or memory usage, everything for this particular port. And those matrices will also be having an attribute which is actually containing port name. Now, all the three somewhere, some point has an attribute which is containing a port name. But think of a scenario where in the trace, that key value of that attribute is actually host name. In logs, that key value is actually port name. And in matrices, that key value is just port. The value is same, but the key attribute is different. Host name, port name, and port. AI will be completely confused. To be very frank, it may not be able to correlate these three, that these three nothing but same, having a same value, right? And that's where the data quality issue comes. If your logs, your matrices, your traces having a similar attribute or having an attribute which has the same value, but the key is different, there's a data quality issue in there. And when you use a different tooling, you might be using tool A for logging, tool B for traces, tool C for matrices. There is a higher chances that this issue will arise. And that's where OpenTelemetry comes into picture. OpenTelemetry actually trying to define these keys in a standard way. So either you use in logs or you use in trace or you use in matrice, the key name should be the same. That's where the OpenTelemetry is trying to define. And when you use that OpenTelemetry as your monitoring agents, and it's emitting a standard semantic conventions, it becomes very easy. Your quality of data is a lot better compared to if you are using some custom build or some different tooling on that. So that's where the OpenTelemetry come into picture, and that's why I say data quality actually equivalent to OpenTelemetry when it comes to AIOps. So OpenTelemetry is an open source standard. It defines semantics, as I said. It defines schemas for all the keys. It tries to make sure trace log matrices are actually following that standard. It has its own agent, which when added to application can start emitting traces. When added to your infrastructure, start capturing your infrastructure matrices like CPU usage, memory usage. When added to your application and used properly, it can actually emit your logs in a standard format too. So all the three matrices, all the three signals, they start getting the same semantic convention when the OpenTelemetry agent is used. And if OpenTelemetry agents or SDKs are being used across all your microservices, they are emitting the same schema altogether. So port name used in trace, port name used in uh, matrices, and port name used in logs, they are same. So it says ktest.port.name. That is the standard name for that now. So that if you are using OpenTelemetry, all three will use that name to mention that. And AI is happy. It knows that there's a key. It has the same name. That means it's containing the same logical value. So it can actually correlate with the value and start doing some correlations and other stuff in there. So that the data quality, I think I covered most of the things. It defined trace semantics, log semantics, metric semantics, everything. Give you a control. It's a flexible. I will just skip that, not related to AIOps, just the advantages of OpenTelemetry. Now let's go into model selection. When you are doing an AIOps, right, you want to use a model which is accurate, which is actually helpful to you. Okay, I'll just again stop to see if there are any questions. I see there are a lot of polls which is coming in. Guys, I strongly suggest if you do poll, uh, uh, give your option and the poll select your option. Contribute to the polls. Okay, I see. What are the AI tools or technologies we can use to set up observability and alert? Is the next part which will be covering Ayush. So that's where maybe you need to wait for that. You will surely get that answer. I don't see anything else. Let me go back. We still have around 20 minutes. Model selection, accuracy, and explainability. I think we talked about explainability already in the first slide. If AI is saying something, it should have able to explain it why. So what are the models actually, right? If you know AI, you know ML, right? You have Gen AI, of course, LLMs. You have predictive and regressions. That's the statistical based models. You have a causal analysis. That is another model. There are different type of models which are available. We need to select one of them to figure it out what is correct for AIOps. So we want a model which gives us accuracy, which gives us explainability, and which gives us reasoning on why it's actually selecting that option. So let me take a couple of capabilities which we talked about in the past. I will take two examples: anomaly detection and correlation, and then we'll try to see which model actually fit in. What is our use case, what we want, and what is actually which model actually fit in correctly. So this is something I actually how you do anomaly detection. I think I covered in the previous thing. Your AI or your can actually start predicting the values based upon your historical seasoning, historical things, and start comparing it with your normal. And if it goes beyond something, then it actually alerts. So that's what we talk about matrices. But what about traces and logs? That's become very interesting actually. Metrics, everybody know what anomaly detection is, but in traces and logs, what anomaly detection is. In most cases, my flow of a request goes through 5 microservices, 4 DBs, that is 3 caching layers, or maybe one integration. Let's take that way. But something wrong happened. Something happened that today it started taking from 5 microservices, it started going into 7 microservices. Instead of running 3 SQL statements, it started running 5 SQL statements. Instead of going to one integration, it started going to integration twice. There's something wrong. That's the anomaly when it comes to traces, right? And this is something most of us, at least wherever I have seen, people do not able to identify correctly because of the complex environment. Normally traces, right, go into hundreds or maybe thousands of layers. So there are thousands of requests which is happening, right? So if you categorize those thousands in a way that you can actually define a pattern for each request, and then start comparing it that okay, is that same pattern always, or it's different, something different, and actually alert it, that may help a lot. Especially, for example, let's say somebody from the front end has trying to do an SQL injection, right? In some security issues there in the front end, and somebody actually added 4 or 5 SQL to your script, JavaScript, and it actually reached the server side. Server immediately can detect if there is a anomaly detection monitoring is there. It can immediately detect that in the past it used to be having 4 SQLs, but now it actually running around 6 or 8 SQLs. There's a different set of SQL which is getting executed by this path. So something is wrong, right? You can easily detect that there. Another use case, somebody has delivered a new patch to one of the microservices. It has written 2 extra SQL to that API. Earlier it was 4, now it's 6. Something happened. Performance is actually gone very low for this particular. So you can easily anomaly detect that there are 2 additional SQLs got added. So there can be one doubt: does these SQLs was optimized? Are these SQL are the problem because of which your response time is going high? So that's how it actually helps when there's an anomaly detection and tracing. Same for logs. You might be getting 100. I'm a very simple example: 100 lines of logs per second. You started getting 1,000 lines immediately. Something went wrong, right? Some problem. Same goes with events. You might be getting, let's say, one deadlock event per minute or something, but immediately you started getting 20 deadlocks per minute. There's an anomaly. It can be converted into metrics also, but it can be converted into event also. So there's kind of all the three. So deviation from these baselines, right? It is actually it's flagged as a potential anomalies, and that can be alerted upon. And again, as I said, it's not as simple as setting max values. AI can actually do seasonality. It can even check Sundays, Mondays, hour of the day, minute of an hour, second of a minute, month of an year, all those things. And even if you can add your, let's say, festival dates, holiday calendar, and all this to AI, it can even correlate with that. But on holidays, something of that sort happen. Or holidays of November, which is a Diwali festival, come that something can happen. So all those things can be taken care of, which is close to impossible when it comes to define in a manual way. Okay, so let's try to see what sets up. We talked about 3 anomaly detections in traces, in matrices, and in logs. Can one AI model suits all? Maybe. Can there is a specific purpose built model which can help in there? Yes, that's true. In metrics, we generally do a seasonality. We want to go a month or an year back so that it can look at. That means your model requires some kind of a memory, old memory, a month, a year, a 2 years memory. Generally, what happens is when you train your models, right? Generally, it keep forgetting the data or the pattern of the past. So I will not say to remove it, just consider it like our mind, right? We don't see some use case or a scenario for months, we generally forget, right? That's how our mind works. That's how more of the NLP works. You keep giving in them more data, and the previous data does not repeat. It keeps forgetting that thing. So if last November there was a high pattern happened at 6 p.m. in the evening, next November that pattern has never repeated. Your model may forget it about it. So that's where you need some kind of a memory if you want seasonality to be remembered correctly. And that's where long short-term memory LSTM models generally based are generally used for metric anomaly detection. Logs, they're a textual in format. NLP is best for text, everybody know. So NLP model or a bot-based model, they can be used for detection. Traces, they are graphs, right? So you want to use graph neural networks, which can actually give you sequences. It can actually store the paths, this whole service graph, how any of the request goes through, and it actually flags your anomaly in there. Yeah, and it's, it's not that we cannot use NLP across all three. Yes, you can use it, but as I said, right model give you better accuracy. NLP may give you better accuracy also. It's not the case. All the model work on a probabilistic way. The way you train them, the way you supervise them. That's but purpose built model, they can always outshine a generic foundational model or an NLP based model. So these are three models which is very fit into these use cases for anomaly detection. So again, anomaly detection can be of three different categories. You can detect anomaly at a local level. Trace anomalies are detected separately. Logs anomaly can be detected separately, and metric anomaly can be detected separately. But there is a use cases where, let's say, an anomaly in the logs is actually relate with an anomaly in the traces, or anomaly in the matrices actually detect or relate with anomaly in the log. So you want to combine all together. You want to see a holistic view. You don't want to see separate anomalies in each, but you want to see on a timestamp or in a time series together all the anomalies and if they are related. So both ways possible. This is the first one, which I talk about individual. So you have observability data. You put into three of these models. You train them, and you actually start predicting. These models can start predicting, and then you have a logic to compare with your actual value for detecting the anomaly. You can combine them together, which we call it as multimodal model. Again, multimodal model definition is different for the people. Some people believe that multimodal is only the case when you have a different formats, image, video, and text combined together. I generally see multimodal even within the text. You have a different type of data. You have a JSON, you have time series, you have graph databases, you may have an XML databases. So even those different types, I generally see it as a multimodal model. So we can use a single model that can be an NLP or can be any other. You convert all trace log matrices into vector embeddings. If you know AI, you know embeddings is a way to convert any input into a standard definition, standard vector definition. So trace logs matrix all get converted into a metric or in a vector. It represents their value, because now they are into the same format. They can be combined together, fed into a single model, and you can actually start doing anomaly and correlations. So when you detect anomaly, now it's not saying it's a trace or a log or a metric. You can always do a reverse. From the vector embedding, you can try to bring in the actual value, but it generally combine all this together and start showing anomalies together. So that's multimodal model. Again, I will stop here before I talk about the next use case correlation to see if there is any question. So Ayush, I'm sure at least your question is answered partially for one use case. When we talk about correlation, we'll talk about another models and tools which can be used. Okay, so I don't see any questions. I'm jumping back again to correlations. This is where things goes very interesting. Right. So correlation is actually the foundation which help you analyze issues very fast or try to give you root cause very fast actually. And I generally define correlation to three types. So what is the correlation first? Let's try to explain correlation. You have two signals, trace, matrix, and logs, right? So if I have a trace which is coming from a particular port, can I say correlate with logs of the same port or the CPU usage of the same port? So I just want to see them together. So I say there is a throughput or there is let's say error. There's error rate increased at a particular timestamp. From a particular port coming in. I just want to see is there any problem in the logs or matrices of the same port. So you want to correlate. In normal terms, if you just go in a manual way, you pull out the timestamp, you pull out the port name, you go to your log tool where the logs are there, you try to search of that port name, assuming that logs also emitting port name as part of their logs attribute. You actually start putting port name search at the same timestamp. So that's how you correlate manually. But what happens if this correlation goes multi-level? For example, error rates. From error rates, you actually go to port. From the port, you actually go to node, and from the node, you actually go to a cloud. Whatever the cloud here. So there is maybe 4 or 5 level of correlations happening together. It becomes even very difficult. You may be doing alt tab, moving here and there, copy pasting timestamp, copy pasting port names, and doing all those stuff, missing out stuff. So that's can something do it automatically for me? Do this and bring them everything together, give me in a single screen. So what I talked about currently is generally called as a temporal or a direct correlations. Temporal means just based upon timestamp. At this timestamp, my traces are this. At this timestamp, my logs are this. At this timestamp, my matrices are this. I'm just comparing with timestamp. Three tabs, same timestamp. I'm seeing all the three things together. I add it to the port name. That become temporal plus contextual. So port name is a context. So you add at this timestamp for this port, what are the traces? At this timestamp for this port, what are the logs? At this timestamp for this port, what are my matrices available? So you use temporal and direct. Up to these two, manual are possible, though it's very complex. If it's a distributed system with multiple levels, still complex, but still possible. The third type of correlation, which we call it the causal correlation, is very something which only AI can detect. So there is no direct correlation. Let's say you get a JavaScript error at the browser, and then there is a database deadlock happening in the past. These two things just cannot be correlated. I don't know if there is a possibility. You might miss out some of the context already. You might forget to add DB name. You might forget to add DB servers in your traces, right? You just cannot have all possible attributes related to a particular resource. So you might miss out those stuff. So those relations cannot be detected using this context. But when you add this to AI can try to detect it. It has deadlocks which is happening. It has JavaScript error which is happening. It can see the history and it try to see the correlation. It can try to figure it out that whenever the JavaScript error rises, at this time deadlock also rises. When it is reduced, it also reduces. So this is one-to-one correlation. There may be possibility of one to many. When JavaScript error increases, as well as server-side CPU usage increases, as well as cache hit increases, then there is some deadlock at the back end. So there are 3 or 4 combination. When all these combination got increased, I see there is a deadlock. So this kind of correlations called causal correlation, they are not immediately known. And many a time, most of our RCAs or most of our complex issues are because of this causal correlation. It is very difficult to figure that out. And that's where the AIOps works. So that's the third type of causal correlation. So we'll talk about this. These two are most of the tool supports. You go to any observability tools, temporal and direct correlation, generally they support. Causal is correlation where AIOps has to come in, otherwise it's very difficult to achieve. So let's talk about how causal correlations can happen. So let's first talk about what benefit causal AI gives. So of course, as I say, these correlations, right, which are not directly related, how will you explain that? Right? It's very difficult to explain. But AIOps, because it's seeing the historical data, it can explain. It can tell them that in the past, when these three combinations happens, we see some issue, we see some downtime. When this 5 or 6 matrices along with this trace flow together, when it happens, we see some issues. So it actually can give you a historical thing. It can actually give you those causal relations that this has happened in the past. It can show you graphs that this is what happened in the past. It can explain but this is because of this. That's why I say explainability is higher in case of a causal AI. Causal AI is nothing but it's actually trying to define relationship between various variables, cause and effect relationships. If something changed on one variable, what happened to the second? It actually try to detect that, try to formalize, try to get that formula how this relationship happens. And it creates that causal graph. In the right hand see if you see there, right, this kind of a graph it creates with what whom is related to whom and how one change actually can change the whole graph. What are the changes happen to other nodes when one changes there? So this provides some kind of an explainability. It actually gives you those 5, 6, 7 causal relations along with direct relations, both combined together, and it actually explain why this is happening. So, what is a causal AI? I know few of the causal AI models which are available. I know 1 or 2 tools which are already using. They are actually based upon Bayesian network. If you have learned or you have seen any book of AI, if the Bayesian network is very uh, particular strong concept which actually draw this kind of a causal relations, one variable impacting another. Lingam is one of the uh, important causal AI model. I know a couple of tools are trying to use that linear non-Gaussian acrylic model. So they try to put out important matrices out of observability tools, try to put into this model to understand if there is a causal relation among them. Of course, cost is a big factor because it's a new model which you are training. There is a cost involved, so you don't want to put all the observability data, all the matrices, but important matrices, putting into that, trying to figure it out if there is a causal AI, there is a causal relationship among those matrices, and use that causal matrices to figure out RC and other stuff. So, what is the process? We collect the data, we discover those causal relationships by adding it to the model. That model learn it. We create that causal model. We incorporate domain expertise. So, causal model is okay, it is AI is detecting, but we know there are some direct relationships. We know pod names and other things, right? So, there are tools which create something called service graphs. This service graph is based upon whom is calling whom. Generally, most of the observability tools do this. So this graph can be added to the existing discovered causal relationship so that you work with both causal as well as direct relationship together. So you incorporate the domain expertise. You start estimating the causal effects now. I mean, you start testing it out. How you test it out? Uh, Generally, the causal model, when they create it, you can query them to say, I'm changing A. Tell me what will be the impact on other variables. So it will give you the prediction. Then you actually make that change in your live system and see if that prediction is correct or not. So you do some kind of a testing in your test environment if causal AI has learned those causal relationship correctly or not. So as I say, right, you cannot train on all the data. This is true for any AI model. You cannot just train on infinite data, but you may want to train on some use cases. And of course, you can keep on iterating depending upon if you want to uh, improve improve the accuracy of causal AI process. Okay, so yeah, before I go, I'll just jump on to question. We have just few minutes left. How do we fix the what are the AI tools or technology? Okay, how do we fix the correlations? We will have to modify the model or work on the training data set false positive. Fix the correlation. I'm not sure what you mean by fix the correlation. Correlation are discovered by the model, right? Uh, so how you want you actually add your own if you know the correlation and you ask what you call AI to actually discover those causes. Yes, if you can say if AI is not discovering that relationship correctly, then yes, there may be a problem with your data quality. So maybe a false causal relationships is being identified. Causality cannot be learned just from data. Yes, agreed. But when you have uh, relationship between those data is well defined, I would say from your service graph or even auto discovery of by AI, it can learn that. But Andrew, I will talk to you on this later, maybe offline. Okay, so let me go on. This is something again, as I said, this is all my learning. There might be possibility that I have misunderstood something, or maybe you can always feel free. We can discuss it later. That's how we learn things. So, in my experience, whatever the tools I have seen in past 5 or 6 months, 80% of the tools are trying to use Gen AI for AIOps. And I always somehow not able to convince myself that Gen AI can give me that kind of an accuracy. Reason because Gen AI is not there for reasoning, right? Of course, lot of us, or maybe if you chat GPT level, they might be trying to adapt it to reasoning, but LLMs or a Gen AI are mostly predicting next set of characters or next set of text from the previous one. That's their ultimate foundational goal, right? That next text may be detected based upon your previous context, right? So it's all depend upon what context you are giving. So if you give them an alert, will it be figure it out what happened or why this is happened? I don't know. It's really difficult to understand. Even if you give them traces, you give them logs, you give them matrices in maybe embeddings, create embeddings, send it across to them. Will they still able to understand those correlations? I really doubt. At least I'm not able to convince. They are more towards chats. They are more towards predicting the next word in the line. If your previous context is wrong, everything is wrong. It hallucinates. So those kind of things is very difficult. Causal because it's trying to define relationships, trying to do cause and effect stuff. That if one thing changes, what impact it has on the other one. So there is a direct relationship with what how we want it observability to work. I want when CPU increase, what impact it will have on my throughput. If my error rate increase, what impact it will have on my user experience. If my deadlock happens, will the failure rate increase? So we want to ask such kind of a question, and that's where the causal is well fitted than the Gen AI. So I just try to compare them. Interpretability, Gen AI difficult, causal AI factual. So yes, Gen AI interpret things, but will it interpret in a way we want? I doubt. Causal AI, it's based on facts. It's based upon how two things are related. So it is more accurate. Explainability, Gen AI will say what comes next. It doesn't say why. Causal AI can say why it's happening. So that it can answer. Data inference, because Gen AI can identify correlations. Little bit superficial. I mean, one example is Gen AI can still try to answer you question even if it hasn't seen that question in the past. It just try to build up something. That's what most of the Gen AIs do, if not accurately. It might not have seen one use case, but because it has learned something, it just try to just build up a solution. That will not be the case of a causal AI because it's based upon relationships. It can actually explain why it's saying so. So yeah, so same way root cause analysis. It's based on prediction. That is based upon factual. There's a counterfactual. We test it out. We ask them question why. Auto heal action because we know the reason correct. Of course, your runbooks can be more accurate. Your runbook can be executed successfully in the first go itself. So that's a comparison. Okay, this is what I came up with. I think this is my last slide, and then we'll get into the questions. What I feel again, as I said, this is my work. You can always uh, counter that, and we can always discuss. You have an historical data from your observability. You pick up important matrices, important traces, important logs. You fed into two pipelines. One is the causal AI pipeline and one is the LLM pipeline. Causal AI try to build a relationship diagram, causal graph, and an LLM pipeline will try to understand those characters or the text and their relationships with those texts. So there are two different type of learning. There are two different type of models get created. When your observability tool is working, you put the same signals which you use for learning to this model and try to see if there is any kind of a issue comes in. I mean, if let the CPU is increasing, will it generate an alert or not? If there's any other issue comes into not based on those relationships, you can query that or say or ask Causal what happened if my CPU is increasing, which I'm saying what can it impact my application or not? So you can ask such kind of a question. If something is impacting, you can always put it into an LLM model, the output of the causal AI, that relationship, that will become a context to LLM. That okay, these four matrices are related and this is increasing. And LLM can actually read from the historical data and make it as a contextual based, right? So in a way which can be easily interpretable. And then you can actually send it to an alert system to actually do an alerting on top of that. And you get the kind of an alert which I showed into you in the first page, right? Something of that sort is possible. Of course, your engineers and agents can directly query the causal model. They can easily say, okay, for other use cases, for example, what will happen if I double my CPU? What will happen if I double my memory? Will how much improvement it will have on my response time, or how much improvement it will have on my error rates or something of that sort. So those kind of a queries can be put and that allow you to fulfill other use cases like predict like planning for future or future loads or some kind of a sales or some kind of that is also possible. Okay, so I'll just skip AIOps advantage. I think we all talk about a lot. Agentic AI, I will just skip it. So yeah, thanks a lot. This is my QR for my LinkedIn. In case you want to connect with me on LinkedIn, you can scan it. Just ping me whenever you are connecting with me. Please mention why you are connecting. Generally, I do not accept if there is no note added. So please just add it why you are connecting with me. If you know me very well, all good. You don't have to. But if when you don't know me, then please add why you are connecting. You can say you attended this webinar, or you are also from SRE, or you are also implementing AIOps, or if you want to discuss some kind of an architecture or some kind of an implementation details, some kind of a plan, feel free. Okay, so I'll just jump across again to any questions. I do not see any questions. So let me just have a look on those polls, see what the result of that poll is. In the meantime, if anybody has any question, please do type. I'll just wait for a couple of minutes. If anybody is still trying to think of or trying to put any question. And let me check in the poll in the meantime. So how would you define observability in one word? Visibility, insights. Great. I also understand insights is something I really want to see. What is your biggest challenge in implementing observability? Data overload and noise, difficult root cause analysis. That's great. RC is something I always find difficult, and noise, both of them. So alert noise is something which is like that's because we are doing a lot of maybe we are monitoring a lot of attributes which are not required. Again, open telemetry allow you to do some kind of a filtering before you actually send it across to backend if you don't need it. Okay, so let me instant. Okay, where is that? I just see this poll name. I think something problem with that poll. How often do you experience false positive in monitoring? For me, I will say 70%. I don't know what people think. For me, I see a lot of false positive, and that's why we like to get into AIOps very frequently for me. Okay, so yeah, so okay, so I do not see any questions. So thanks, guys. Thanks for joining.